Welcome to Electro. My name is Stan Pyler. In this video presentation, we're going to be reviewing the operator instructions for the Model 2 SAC. The 2 SAC is probably one of the easiest machines you'll ever operate. Its automatic feed feature pretty much does everything for you. Alignment is easy. Basically, in most cases, the part is going to be heavy enough so that we can just set the part on the tabletop, swing the head around, align the electrode roughly about 1/4 of an inch off the top of the broken tap, and lock everything into position. And now the operator will basically start the machine. The head will feed down and start the process. He will monitor the current and adjust the feed rate controller to the appropriate feed designated by the chart located on the side of your machine. Let's take a look at the power panel of the 2 SAC. We'll start by looking at the upper left-hand corner. We find a circuit protection fuse, twist lock type, of 4 amps. Next to it, to the right, this is an up-down, left and right jog controller button. To the right of that is our amp meter, 0 to 100 amps. To the right of that, power on. This is a yellow illuminated light. To the right of that, a green start button. Directly below that, our stop. This will completely shut the machine down. And to the left of that is our pump on and off selector. Picking up to the left, center, we find vibration, on and off, manual control, a circuit breaker for the disintegrating circuit itself. Below that, cutting power, rotary switch ranging from the off position to a heat selection of number 11. To the right of that, servo feed, and this control ranges from 0 to number 10. And finally, vibration amplitude, another rotary switch ranging from 0 to a number 10. The machine has 3 modes of operation. The first being more of a mechanical operation. Simply, what we use this mode for is to turn the machine on to check out the different functions of the machine. For example, head vibration. Should the machine require head adjustment, the operator could go to the manual mode and simply start the head vibrator and make his adjustments appropriately. Same goes for the on-off control for the coolant pump. If he's having trouble with the pump or motor, or simply wants to clean the tank or flush the system out, he can use this control to accomplish those tasks. The machine can be operated in a manual mode. With our servo controller at 0, head vibration turned on, coolant on, and selecting a heat, the operator can manually use his hand wheel to downfeed and take out the broken tooling. Let's take a look and see how that's done. We've got a 3/8 tap broken off into this block of steel. We're going to be inserting a 187 electrode into the spindle to take that broken tool out, the 187 being half the diameter of the tap size. I put a 187 electrode into the spindle. She's locked in secure. Always want to be sure with your crescent wrench or open end wrench to give it an extra little twist to ensure that that electrode is in fact secured into the spindle. If it's not, there's a good chance that the threads of that brass nut will be disintegrated. So keep that in mind. Next, using an Electro Arc splash bag, we're going to slide that up over the brass nut and secure it with a 1-inch O-ring. This will keep you and I both dry once we get this machine turned on. Bringing the head into position is pretty easy. Basically, we have radial movement of our column, which is 50 inches in height. we have in-out movement of the disintegrating head, pulling the head out toward the part or pushing it back in. Those are the basic operating modes. And then we have, of course, rotation of the head, which is a full 360 degrees around the crossarm. And all of these are locked into position with simple mechanical hand locks. The underside of the 30-inch crossarm has been beveled out, and a rolling spring-loaded ball will let you know when you get back to that perpendicular position. Also notice off on the right-hand side, we have our lift rack assembly. This is a 12-inch lift rack, and simply by rotating it either clockwise or counterclockwise, we can raise or lower the disintegrating head, getting it into its rough position. Once we've brought the head around, we've got it pretty well in the center of our travel of our 12-inch quill. I'm going to use the hand crank to bring it down a bit more, trying to position the head and get it set up in its most rigid position. Once I've got it to the height that I'm looking for, I can simply snug that up and hold it into position. Now I'm going to align the electrode in this plane, getting it directly over the center of that broken 3/8 tap. Now that I'm happy with the electrode sitting directly over the top of that broken tap, both in the left and right direction and on center in the front to back position, I can pull my splash bag down, and I'm going to use some shop rags to help hold that plastic bag down to contain that coolant splash. With everything locked into position up top, we're going to go ahead and start the machine. To do that, first we're going to simply turn the machine on. Pushing our green on button, we notice that the fan starts blowing in the power supply and the yellow illuminator is lit up. Next, we're going to select a heat range. For the 187, our chart on the side of the machine is telling us that we can use heat range 5 or 6. We'll start with number 6. I turn my cutting power to number 6 at this time. Next, the chart also indicated that we're going to use a 6.5 head vibration ratio. Using my vibration amplitude knob, I select or rotate the knob to 6.5 or 6.5. Now we can turn the head vibration on and coolant. On the side of the head, you're going to find two discs, an inner and an outer disc. The outer disc will essentially move the head or quill assembly in an up-down direction. The outer disc is a clutching mechanism that will engage the auto feed or disengage it. Remember, our servo controller is currently at 0. So what I'm going to do here for the manual operation is to rotate the inner disc counterclockwise, which loosens up the clutch assembly and will allow me to downfeed. elected, I could continue to downfeed through the tap and complete the operation manually. At this point, what I would like to do is to shift into the automatic mode. To do that, we're going to have to take a look at the chart on the side of the machine and see what kind of heat range or amperage draw we're going to be running this machine at. In the meantime, let's shut the machine off and we'll start again for the auto feature. You'll want to notice also on the auto feed, I do have a depth stop and a depth stop limit switch at the very front of this casting. At the back, you'll find another micro switch, which is our remote start-stop switch. We'll take a closer look at those in a second. The electrode selector chart gives us those detailed information bits that we're going to need for setting up the machine electronically. Let's take, for example, that 3/8 tap. For the 3/8, we see the first thing, or the column to the right of the 3/8, is the electrode size. That's our 187. Next to that is the actual drill tap size, which is a 323. To the right of that is our head vibration setting, 6.5. To the right of that is our cutting power, and it's telling us that we can use either a number 5 or 6, and the amperage is going to be set at 35 to 45 amps. To run in the automatic mode, I'm ready to set up my operator's panel, first by setting the vibration on-off switch to the on position, coolant pump to the on position, cutting power, we're going to use a number 5, head vibration amplitude to 6.5. Servo feed is going to stay at 0 at this point. The machine is electronically ready to go. But before we start, I want to point out those remote buttons on the quill assembly of our spindle. At the front of the quill is our depth stop, a micro switch located at the very front of the casting. And to the rear, we notice our remote start on button. The remote depth stop is a handy tool to be used to automatically shut that machine off once we reach the depth we want to get to. It's very easy to calculate that ratio because we know for every 1 inch of material that we remove, we're going to use 3/8 of moly tubing. Knowing this, what I can do is I can drop my head down, I'm unlocking my clutch, lower the head, touching the broken tap so that it's sitting on the top surface, and I know that that hole, okay, is 3/4 of an inch deep. So what I can do is bring my depth stop down, set it on top of the micro switch, and take a look at my scale, which is mounted to the head assembly, and measure up 1/4, 2, 3/4 of an inch for the depth, and then 3/8 of an inch for the erosion of the electrode, and set my depth stop. Now, in position, what I want to do is back the head off about 1/4 of an inch so that will give the servo enough time to get itself going. Lock the servo into position, and we just barely have to snug that into position. Also, we want to be sure to release our coil spring for the anti-fall. That way we don't have any additional force being put on the auto feed motor. With everything in place, we're ready to go. First thing I'm going to do is use the remote start stop to get the machine or the head pump and head vibration in the go mode. Coolant's flowing, head vibration is ready. Now what we're going to do is we're going to start to increase the servo feed and monitor the amperage on the amp meter. Remember, the chart had told us 25 to 30 amps for the 187 electrode. Because of the head vibration, the amplitude is obviously cycling in that same up-down frequency. So what we're going to want to do is make an average. Take your low and your high, average them together, and pick the middle. Right now, I should be running right at about 30 to 35 amps. The machine will continue to burn until it reaches the bottom of the hole, and at that time, the depth stop will shut the machine off. We've reached the bottom of the hole. The machine has automatically shut itself off. And now we're going to take a look down inside and see what we've got. Using our Electro magnetic tapered pick, I'm going to go back down into that hole and just basically clean it out. There we see the core of the electrode, or excuse me, the core of the broken tap. More remnants of the threads. In most cases, it's not necessary to go back in with a tap, but I always recommend that a bottoming tap be sent back down the hole to clean it out and make sure that all the broken tool bits have been removed. Now that looks pretty good. Let's zoom in and take a better look. The threads are perfectly intact. The part is cosmetically and mechanically perfect. Whether it's high speed or carbide, drills and taps are easily removed. And don't forget about those tools in the tool crib. Dowel pins, drill heads for removing compact bits. Thank you for your purchase. Should you have any additional questions, please feel free to contact us at any time. Electro has manufactured the metal disintegrator for over 57 years. We are, in fact, the largest manufacturer of metal disintegrators, offering a full range from portables to tabletops to special machine tools. Should you have any further questions, please feel free to contact us at any time. This is Stan Pyler from Electro. Thank you.